Hi everybody. I hope this mic is on. Yep, it looks like it's working. Great. Today we're going to take notes, and the notes, there are going to be some questions involved too, but you want to start by getting your notebook ready for notes. And so you can pause, and when you're ready, come on back. Okay, so the title of today's notes are, can I erase that? Yes, there we go. The title of today's notes, I think I'm out of practice here, are rules of exponents. And we're going to learn some rules of exponents. And rules of exponents help us work with numbers, big numbers, in a easier and simpler way. So just to remind you, that says rules of exponents. Just to remind you, the 3 is the exponent, and the 5 is the base. And an exponent is a way of communicating repeated multiplication. So 5 to the third is equal to 5 times 5 times 5. And the mistake that sometimes people do is they do 5 times 3. So a lot of our rules are going to talk about like bases. And what that means is when you have two exponential expressions, like let's say 6 to the 8th times 6 to the 5th, we have like bases here because they're both 6s. Because the 6s are both bases and they are the same number. So like bases. Okay, so I'm going to erase this. This next part you actually don't need to take notes on yet. You might want notes. You can decide at the end and pause and take notes if you want. The first rule that we're going to look at is called multiplying. Maybe you better take notes. Sorry. Multiplying like bases. So there that is, that like bases. And in this case, we're going to multiply like bases. So an example of multiplying like bases might be 5 to the third times, and often the times is a dot, because if we use an X, then we're not sure if there's algebra involved or not. 5 to the third times 5 to the 4th. Okay, so 5 to the third, I think you would agree, is 5 times 5 times 5. So there's our 5 to the third. And then we have times 5 to the 4th. 1, 2, 3, 4. So there's 5 to the third times 5 to the 4th, all the way written out, which is not something you ever really want to do. But I'm doing this to show you something, because 5 to the third times 5 to the 4th is also the same as, that green might be a little light. I think I'm going to switch that color. Let's see. How do you guys feel about magenta? There we go. So 5 to the third times 5 to the 4th, we have 1, 2, 3, 4, 5, 6, 7 is 5 to the 7th. So you might see in a math problem, simplify 5 to the third times 5 to the 4th. That's supposed to be 4. I'm not erasing everything. Just 5 to the 4th. And your answer is 5 to the 7th. You don't have to do out. You don't have to multiply 5 times itself 7 times. You just answer 5 to the 7th. Okay? And I'm going to ask you, what if we had 6 to the 8th times 6 to the 10th? Can you tell, based on what we did here, what that might be? If you got 6 to the 18th, you were correct, because when you multiply like bases, you add exponents. So for your notes, when you multiply like bases, you add exponents. That's all there is to it. 6 to the 8th times 6 to the 10th, 6 to the 18th. Just take those exponents and add them. Oh, I should have told you I was erasing. Sorry. Okay. The next one we're going to look at is divide like bases. And this time we're going to look at 6 to the 5th divided by 6 to the 3rd. Okay, and I'm going to write that out. So 6 to the 5th is 6 times 6 times 6 times 6. And 6 to the 3rd is 6 times 6 times 6. Now, you know that if you have 6 over 6, that is equal to 1, because you can divide the top by 6 and divide the bottom by 6. You get 1 over 1, which is 1. Okay, we're going to do that here. We have 4 6s on the top. Oh, I'm supposed to have 5 6s on the top. There we go. 5 6s on the top, 3 6s on the bottom. And we're going to divide. We're going to cross cancel here, or reduce. We're going to divide by 6, divide by 6. And then we're going to do it again with this pair. Divide by 6, divide by 6. Then we're going to do it again with this pair. Divide by 6, divide by 6. And we have 2 6s on the top. 1 times 1 times 1 times 6 times 6 is 6 to the 2nd power. And on the bottom we have 1 times 1 times 1, 6 squared over 1, which is 6 squared. So if you look, 6 to the 5th over 6 to the 3rd, we could have gotten that squared by subtracting exponents. So when you divide like bases, you subtract exponents. So for example, 7 to the 14th, 7 to the 19th over 7 to the 10th is 7 to the 19 minus 10, which is 7 to the 9. Done. All there is to it. If you're dividing like bases, and I'm going to point out again, we have like bases because they're both 7s. Okay, one more to do. I'm going to erase this. The next one is called power of a power. An example of that might be 5 to the 2nd to the 4th. So that's called power of a power because you have a power here and then you have a power here. So 5 to the 2nd to the 4th is 5 to the 2nd times itself 4 times. So notice here we are multiplying like bases. So the rule is when you're multiplying like bases, you add exponents. So this is 5 to the 2 plus 2 plus 2 plus 2. Another way you can say that, because there's 4 2's, is you can say 5 to the 4 times 2, otherwise known as 5 to the 8th. So when you have a power of a power, you multiply exponents. I'm going to erase this. I'm just going to recap. So this is rules of exponents. Recap. When you multiply like bases, in order to multiply like bases, you can add exponents. And so multiply, if you're multiplying like bases, the exponents get added. If you're dividing like bases, and this kind of makes sense, right? If you divide like bases, you subtract exponents. And power of a power, you multiply exponents. Power of a power, well, I guess I'll just circle power. You multiply exponents. Okay, and hang on, I'm just going to pause for a second and then I'll be right back. I'm just going to pull up a problem for us. Okay, I'm going to erase this, so if you want to catch it, you can pause. So sometimes a problem might have more than one rule of exponents in it, so you might need to use more than one rule of exponents. So for example, like 5 to the 3rd to the 4th over 5 to the 2nd times 5 to the 5th. Okay, so if you want to pause and try this, you can, or you can do this with me. I'm going to do 5 to the 3rd to the 4th first. So that's power of a power. So I'm going to multiply exponents. So that's going to be 5 to the 12th over 5 to the 2nd times 5 to the 5th. Next, I'm going to divide like bases right here. So I'm going to subtract exponents. So this is going to become 5 to the 12 minus 2, or 5 to the 10th. 5 to the 10th times 5 to the 5th. Then, that's supposed to be 5. Now I'm multiplying like bases. I'm going to add exponents. That's 5 to the 15th. A lot simpler than this ugly expression. So that's why we simplify exponents. Sorry for the long video today. I missed you guys over break, and I'm looking forward to seeing you tomorrow. Hope you're doing well.